It's what the challenge is every day. Everyone has their own unique approach trying to get that done. And that's what's great about the job, is that it's different almost every single day.
We've got some robots, some droids in front of us. We started from very basic structures with a huge ambition, ultimately, to get that state you're talking about. And now here they are. Talk to us about the progression.
Yeah, we actually started with this humanoid test character. Can we get 2 legs to do stylized walking? We have characters that express emotion through motion. So stylization is important, artistic interfaces are important. And we embrace reinforcement learning as a technology very early on. Reinforcement learning is the way we learn actually as humans. That's an algorithm that brings this capability to a computer. And so we train them to imitate artist-provided motion. They learn to balance at the same time.
Do they actually learn?
They do learn and imitate basically how we humans learn. And over time, really polished motions.
One of the things I think is really interesting is the use of machine learning and AI in order to develop the robotics.
Reinforcement learning is a branch of artificial intelligence, which allows us to take animated figures, bring them into simulation, and then teach them how to walk as if they were a young baby. We can do 10,000 hours worth of training in days. It used to take us years to develop robots. Now, using reinforcement learning, we're able to bring those robots to life in mere months.
Espen, do you remember how I challenged you to create actually a first walking character with 3D printed parts and off-the-shelf actuators?
So you said, can we build a walking robot? And I said, well, I think it'll work, but I don't know. And you said, well, let's do it anyway. If we can use 3D printing, we can build something really fast. Can we make that work? Key idea was, can we, instead of trying to build a perfect, idealized system, let's build an imperfect system and instead try and understand it really well in software. We first took a single actuator and we put it on a test stand and we tried to understand how this thing behaved and moved. Now, when we put it together, we tried it and the RL walking worked first time.
Yeah.
Never happens.
Never happens.
It's a solid foundation that we've then been able to really build on. So this guy doesn't look anything like a BDX droid, but if you really look under the hood and look at what makes this work, it's all building on the same technology, and so this is really what enabled us to then go and build the BDX droids.
We know how humans walk, and so the goal was then, how can we bring this human motion to our robots to make them feel lifelike, and we want to have those robots also perform other motions. So our goal was not to have the robot learn only a single motion from an animator, but be able to perform any motion that an animator asks the robot to do. From the human motion, we first have to retarget them to the morphology that we have here. This character is a bit smaller and you get a lot of imperfection, but then in reinforcement learning, it still is able to learn from this imperfect data, and it extracts basically the knowledge of how does a